Today we are going to do section 3.1 functions. We're only going to do part 1 because this section is a bit long. Okay, so we'll finish it in the next video. First, let's talk about what a function is. A function is something that if you enter an input value, it's like a machine. If you enter an input value into a function, then it will spit something out according to a set rule. For example, you might have a function that's called 2x. Okay, what that does is when you input a number, say 1, okay, it will spit out 2. And it's your 2x function. So generally, if you input, say, -1, it will spit out -2, and so on. So generally, your function is doubles whatever you put in, okay, whatever it might be. Now, the function is defined in a bunch of stuff on this side, which is things that you're allowed to put into the function. That is called the domain. And the stuff that spits out, all the stuff that will show up at the end is called the range of the function. Okay, and so the function generally takes something from the domain and spit it out into the range. Well, you might think, well, can the domain be just anything? Not always. For example, let's say I have a function where it equals to 1 over x. That is, anything if I enter 2, okay, my function will spit out 1/2. Then in that case, everything can be on this side except 0 because you cannot divide by 0. And therefore, 0 cannot be in the domain of this particular function. So in general, a function is something that takes something and gives something back out. Now, when is something not a function is sometimes it doesn't give anything. It says, I don't know what it is. Then it is that's not acceptable. Okay? Or if it gives out 2 things, if sometimes you have a situation where the function gives 2 different things, it's like if you ask what is the direction to something like your sister's house, and the computer program gives you 2 completely different directions. That is not acceptable. Okay, that is not considered a function. So a function will give one specific answer to each input, and that is considered a function. So let's go to page 184, example 2, where we consider the class grades. Class grades is you have a percentage grade, what percent you get, and that gives you a grade point average. Now that is a function because each percentage grade gives you a very specific grade point. You wouldn't have end up with two different grade points for the same percentage grade. So that is a function. All right. Now the function that I should, however, mention something that the book mentions is called a relation. Let's go back to page 182. I want to quickly mention this parentheses situation where we have a bunch of parentheses like 1, 2. Okay, I'm on page 182 where you see a bunch of numbers like this: 1, 2, and 2, 4, etc. Now what that means, this is called a relation. A relation is assigning each number 1 to the result of 2's. So this is called a relation. 1 goes to 2 and 2 goes to 4. And that's called a relation. Now, this is also a function because each number 1 is assigned to a very specific number 2. Now, what if I also say that 1, 3 is here? Then this is no longer a function, okay? Sometimes 1 goes to 2, sometimes 1 goes to 3, who knows where it goes. So that is not considered a function. But this thing is, I guess is called, this is still called a relation. Well, anyway, that's all I want to say about that. So let's go back to page 184. So at the bottom of the page, let's consider the function notation. Now the function is often called f, for good reason, right? And then the result is often called f of x. That is, whereas what goes in is called x. So then x goes into the function f, okay? And then the parentheses means that's where you stuck x in there, and the entire thing here is the result of the function. So the function itself is called f. And that's good. So that's the notation, so that when you see f of x, you know what that means. It means we will take x and do whatever it says. As an example here, then would be this function is described as f of x equals to 1 over x. That means anytime you enter the x in there, whatever you want, like say 1, right? The function will take 1 and do this process to it. And of course, the function we have to specify that in this case, x cannot be 0. Do not throw 0 in there. You'll jam up the machine, okay? You'll just fall apart and die. So please don't put x in there, but anything else is fine. So let's look at the next page. So I'm now on page 185, and let's look at example 3, where we are considering the days of the month. 5. That's a 5. Okay, the days of month, is that a function? That each month has so many days, okay? So you can have a which is a function because each month has a specific number of days. So it goes to, so we can consider that as a function. Now, if you don't consider the fact that February sometimes changes its value, and so we will ignore that, because if you consider that, then it's no longer a function. Okay, so so then, let me see. Yeah, it says right here, we're not considering the leap years, okay? So as long as February has the 28 days, like it's supposed to, and not have the exception, then it is a function. So next let's consider example 4, where we have a function that's called n equals to fy. What does that mean? Well, y stands for the number of police. Y is the year, and n is the number of policemen in a town. So is that a function? Sure. Each year has a set number of policemen, right? And so that is that we will consider that a function. Specifically, f 2005 equals to 300 means in the year 2005 the town has 300 police officers. And yeah, so that's the function. Let's move on. Okay, and the function can sometimes be represented as a table, like the previous problem when we mentioned the month, each month, how many days in the month as a function. So we can write the function like this. Okay, instead of the symbol f, we can say month 1 goes to 31 days, and month 6 is 30 days, etc., etc. See, a lot of the months have the same days, and that's okay. Just as long as the function tells you each month, when you put the stuff in your function, it will spit out the days for each month without ambiguity. Okay, that is, there isn't a month that it doesn't know how many days there is, or maybe there are 2 options. Like I said, we're ignoring the fact that February can be odd sometimes, and just pretend that it's the right time or right numbers. Okay, so let's look at, here's a table. Is this table a function? Okay, now so we'll look at all the elements of the table. Does it give you a reasonable output? So we split 2 gives you 1, input 5 gives you 3, input 8 gives you 6. Yes, so that is a function. Now let's look at the next page. My page won't flip. There. And then the second table, similarly, that looks good, right? Each number, they give you something out reasonably. Look at the third table. It repeated 5 twice in the input, which gives you 2 different values for 5. Therefore, that thing is not a function, because a function will give you a specific answer, not like, why does it have 2 answers? Well, which one is it? We don't know. So in that case, that is not considered a function. Okay, so next, let's look at example 6. Now from example 6 onward, please do it as part of your homework. The others are just a quick introduction that I don't really see why you should have to do it yourself. And so let's look at example 6. Okay, evaluating functions at specific values. That is actually an important thing to learn in algebra. So let's. So what are we talking about? We are talking about the function is defined in this case as a quadratic formula. That quadratic. Well, it's a quadratic. okay, expression. So then we need x to be 2. So to evaluate it just means that we plug x in the fx right here, okay, that becomes 2, and which means the f of x describes it as you will take what's in here, which is x, and do all the stuff to it. So x becomes 2, we have to square 2 squared plus 3 times 2 minus 4, and figure out what that is. Okay, so 2 squared plus 3 times 2, that's like 10 minus 4 is 6, right? Yep, it is. So that's how you do it. Now, what if you plug in, instead of 2, we plug in a symbol, and let's say plug in a, just a, okay? Now, if we were to plug in a, then f of x, f of a becomes f of a, because we plugged in a. Then we just copy the whole thing down. F of a is then a squared plus 3a minus 4. Being that we don't know what a is, that is the answer, okay? And then, so for the next part, we have to plug in what is a plus h. Then that gets more complicated. Then we get a longer answer, right? If you plug in a plus h, it's this thing, and if you decide to multiply it out, which the book decided to do, then you will end up with that thing. And finally, we have even more complicated. And well, then the last part, your book wants you to evaluate that expression, which is doing a division right here. Okay, so please do this yourself. This is a matter of patiently writing everything out. It's long, but it's not particularly complicated. I mean, it's not particularly exhausting, or should I say, it's not particularly straightforward. Okay, you can do it if you spend enough time working on this. So if you do all this, f of a plus h is here, and then you minus f of a, and you clean out some terms and stuff, and eventually you end up with that cute little answer right there. So please do that as part of your homework. And that is something important, that's important for you to know how to do, manipulating symbols and subtracting and adding and all that. If you have trouble doing that, this is done in, in chapter 1. Yeah, this is mostly done, this is reviewed in chapter 1, so please go over chapter 1 if you ever had trouble doing this, mechanical part of algebra, okay? So let's move on to the next page, page 189. Which, let's see. Okay, we have example 7, which we are evaluating. Okay, example 7 is not that different. We are just, we are having h of 4. So p equals to 4, so you plug p as 4, yeah, and the answer comes right out. So please do that yourself. Now, example 8 is different. Now, this time you're giving the result of the function. That is what it becomes, and you're supposed to dig out where did it come from, okay? So if h of p equals to 3, then what does p have to be? So you're solving the equation, which is, in this case, is a quadratic equation. So please go ahead and solve that yourself. And so if the function, which is p squared plus 2p equals to 3, then what might the p value be? Well, to do that, you will solve this equation, which is a quadratic equation, and we will pull those quadratic equation tricks. Now, the tricks will tell you something like it eventually equals to minus 3 or 1. Okay, and they are both acceptable answers, because that means the function will take minus 3 to 3, and then take p1 also to 3. It's okay that the function spit out the same answers, as long as it spit out one specific answer and not get confused and not knowing which answer to get to. Okay, so that is so that's example 8. Please do that as part of your homework. Example 9, we have express the relationship as a function p equals to f of n. What that means is we have an equation here, okay, and we need to somehow plug p out of there. That, in other words, solve for p. And when you solve for p, which is quite straightforward in this case, p then equal to something n, and that will be the function of n. So that is the same thing we've done before. So please do example 9 as part of your homework. Next, let's look at example 10. We have a function. Well, actually, we have some equation called x squared plus y squared equals to 1. Now, if you're trying to plug y out of here, then very soon you will end up with taking the square root, which means you will have, see, from x squared plus y squared equal to 1, then you want to isolate y. So you put y on one side and 1 minus x squared on the other side, and very soon you have to take the square root, which means what? Which means then you have to have a plus and minus value, which means, and that means this thing is not a function because it has two things going to be the same. It has to be just one. Therefore, this equation x squared plus y squared equal to 1 is not a function. Now, your book tells you that that thing is a circle, but if you haven't learned that, there's no way for you to tell that it is a circle. So we really don't care if it's a circle, okay? Well, all we care about is this thing when you take the square root, then it has end up with two parts. So you can't isolate y but with just one value, okay? It'll end up with two values, and therefore it is not a function in that sense. So next, let's look at example 10. Where is it? Now next, let's look at example 11. And yeah, please do the other example as part of your homework. The example 11, we can calculate function if the function is presented in a table form. For example, like let's look at example 11. We have example 11 says we have that function there, okay, in a neat little table. So to calculate and the function is named g. So then g of 3, you just look down. What happens when n is 3? Then the answer is 7. And then And then the other question is that what if the result of g is 6? Where does it come from? Well, you look at the chart and it says 6 comes from 4. So g of 4 becomes 6, and that is the answer to example 11. Now the next problem, example 12, we can also represent function as a graph, and then and check out the graph to see where the function comes from. For example, let's say we have this function, and I'll draw it right here. We have a function that okay, it stops at bottoms out at 1, and we need to figure out what f of 2 is. So we go to 2, okay, and check out what is the vertical value at 2. So when x is 2, this is x and that's y. When x is 2, we go up, okay, it hits the graph, and then we see what the y value is. What is it? When x is 2, it looks like 1 to me. Yeah. So then, so to solve f of 2 looks like 1. So that's the answer. Okay, from the graph, we can see that f of 2 equals to 1. And similarly, we need to solve f of x equal to 4. So what happens when f is 4? Now, my graph is not drawn properly enough to do that. So then we can look at this, okay? Now, when y equal to 4, you look across when it hit the graph, and look down, it hits at 3. See? So then, so what becomes 4 in the function? F of 3 becomes 4. So that is the answer to the question: solve f of x equal to 4. That means x had better be 3. Does it say that? Yep, it says right here. F of 3 becomes 4. However, you notice that there is something else that also becomes 4 though. That is that I neglected to mention, and that is, if you notice that f of minus 1 also is 4. See, f of 3 gets to be 4. F of minus 1 is also 4. They both become 4 on the graph. So the answer is that there are actually two answers. That is, when the input is -1 or 3, they can both be, the output is both 4. Now remember, a function is okay to have identical outputs. They just can't have two different outputs for the same input. So there more than one input can have the same thing. That is, it's like you have a bunch of kids and maybe 3 of them are all called John, and that's okay. But each kid had better have just one name. You can't have a kid that's named John or Mary or something like that. It's or John or Peter, or Mary or Ann. That just each kid has one name, and that's considered a function. All right, so that is let's look at the next thing to decide if a function is one-to-one. One-to-one means that the function has it don't have two inputs that get the same result, like I mentioned earlier. In other words, every kid in your class has a different name. There are no 2 kids with the same name. In that case, that is called a one-to-one function. So in a one-to-one function, you can say John in a class and you won't have 3 kids answering what. so that would be a one-to-one function. Okay, a function doesn't have to be one-to-one, but if it has that characteristic, then it is called a one-to-one function. If you have more than one kid with the same name, then it is still a function. It's just not one-to-one. So let's look at the one. Decide whether some relationship is one-to-one. Well, then, example, what are we doing? Example 13, I guess. Okay, now example 13 is the area of a circle, a function of its radius, and if so, is it one-to-one? Yes, because each radius, the area of a circle, is given by pi r squared. Here's an equation. This is something you need to memorize if you haven't done it already. Okay, that is, the area of circle is called pi r squared, and the question is that function? In other words, if you input some radius, will it give you a specific area instead of spitting out 2 conflicting areas that you don't know which one is the real area? The answer is yes. This is a function because for each input of the radius, you will get a very specific, you will get one area, okay, as a result. So every circle you have, you measure its radius, you plug it in here, and then out spits the area for your circle. No problems. Now, is it a one-to-one function? The answer is also yes, because as your radius is different, then the area will also be different. That is, if your radius is different, then one radius is going to be bigger than the other radius, and if one is bigger than the other radius, the area will also be bigger. Okay, so each radius will give you a specific area. And as a result, the area formula is a one-to-one relationship, or a one-to-one function. So that's example 13. Next, we are going to do something called the vertical test. Well, the vertical test is good for deciding whether a graph is a function or not. That is, you draw something straight down, and if it only hits the graph once, okay, then it is a function. You imagine drawing a line all the way across the function. See if it hits only one time. If it ever hits 2 times, then it is not a function, like those 2 examples. That's because for each value of x, like in here, okay, what is the value of y? Then you have one on top and one on bottom, and you don't know where the function is leading you. Then it's not a function. So the vertical test can be used to test graphs, functions that's represented in graphs, to see if it is a function or not. So let's look at example 14, which is on page 195. All right, and apply the vertical test. Now, if you apply the vertical test, you can just stare at it and do it in your head, right? This one, definitely a function. When you draw vertical lines across, it's only going to hit the function once. Second one, same thing. It's definitely a function. Third one, definitely not a function, because if you draw a vertical line down through the circle, you'll hit it twice, which means it doesn't know which way to go. Okay, the top answer or the bottom answer. So that's the example, 13 or something. What were we doing? 14, excuse me, 14. So that is how we do the vertical test. And the The next thing we're going to talk about is something called the horizontal test. Now, the horizontal test is is only to test if a function is one-to-one. That is, if you draw a horizontal test of a function on a graph of a function. I'm looking at example 15 now on page 197. Now, if you look at example 15, then we have some function in the graph here, okay? And we draw a horizontal line, and we're going to hit it 2 or more times, right? That means if this means that the function at that value comes from more than one spot. It can come from the value on the left side or the value on the right side when you draw the value down. So there are 2 values that will give the function the same result, which still makes it a function, but it's not one-to-one anymore. It's like having 2 Johns in your class, okay? 2 kids, they have the same name. So then you cannot. Then it's no longer one-to-one. So in this graph, as you can see, there's some negative. If we call these things unit 1, okay, at -1, the function is positive 3. Over there, at value 2 point something, let's say 2.2. The function is also positive 3. So they're hitting. So the horizontal line test then explains to you, then can show you if a function is one-to-one, if your function is represented in a graph. Okay, then you draw imagine a horizontal line cut across and see if it hits more than once. All right, so that is that. And the next part of the book, okay, the following of the results, page 197, we will continue this video in the, we will do the graphing part and the rest of the section in the next video.